Hey guys, welcome to this video. In one of my previous videos, I brought about an interesting question, which is regarding the interplay of three important parameters like symmetry, entropy, and energy. So, whenever we study any changes, any evolution of any complex system, then the interplay between these three parameters, symmetry, energy, and entropy, it's very important to study this, and that generates a lot of fundamental insights. Let's start with the universe. So, we know that in the early universe, all the four forces, the four fundamental forces of nature, it is believed that they were all unified into a single force, and it was very symmetric. Of course, the early universe, the Big Bang, that was a very symmetric state. It was very smooth, right? As we already know from observing cosmic microwave background and everything. Now, as the universe has expanded, local clumps of matter, galaxies, stars have formed these structures, and then symmetry has broken in the process. And now today we have four fundamental forces. So symmetry is broken, and this is spontaneous symmetry breaking. Of course, the laws of physics has not changed, but yeah, symmetry is broken. The same thing when a gas cools down and becomes a solid through liquid or even directly. Then also symmetry breaks in the process because a gas has more symmetry than a solid. Consider an infinite box of gas. Let's say you have an infinite box of gas with an infinite number of gas particles. So if you're at any point within this box of gas, you cannot distinguish any region of any point in space with any other point in space within this system, because we have assumed it extends infinitely in all directions and there are an infinite number of gas particles. You cannot even say one direction from the other, and as a whole the system does not change with time, so it's perfectly symmetric. We say gas has continuous translational symmetry because the gas particles are free to move about, and in such a system you cannot, like, it's the same everywhere. Solid on the other hand has discrete translational symmetry because it's a lattice structure. Only the lattice points are the solid atoms. So there is symmetry in solid, of course, crystalline solid, perfect crystalline solid, but it's less than the symmetry of gas. So as the gas cools to solid, symmetry breaks in the process, and as any system cools down and loses energy and becomes more stable, its symmetry breaks or symmetry decreases. The universe is expanding and cooling down and symmetry breaking. Similarly, gas to solid. But one counterintuitive question you might ask is that what about entropy? Gas has higher entropy than solid. Of course, there are many possible configurations for gas particles since they're free to move about, unlike the solid atoms. And we assume that high entropy state is a low energy state, corresponds to equilibrium. But actually, when a gas cools down to solid, it loses some energy in the process. It releases heat into the surrounding. A part of the internal energy of gas is wasted on the process, and it dissipates heat into the surrounding. And as a whole, when you consider the gas plus the surroundings, as the gas cools to solid, then the entropy does not decrease, entropy increases. So there is actually no contradiction here. Okay, but yeah, it's true. Like in general, as a system cools down, and I mean it moves more towards stability and equilibrium, its entropy will decrease, its entropy will increase, and energy will decrease. So yeah, I hope you found this discussion insightful. Thank you.